Hey everyone, Namaste. Welcome. आज हामी च्याप्टर 3 क्वान्टिटी अफ वाटरलाई एकदम सिम्पल तरिकाले बुझ्ने छौं। यो भिडियोको एन्डसम्म कुनै पनि सिटीको लागि वाटर डिमान्ड कसरी क्याल्कुलेट गर्ने त्यो सब क्लियर हुन्छ, which is, super important for your exams.
ओके, सो सिधै टपिकमा जम्प गरौँ है। जस्ट इमेजिन तपाईँ एकजना इन्जिनियर हो र यु हेभ टु डिजाइन अ न्यू वाटर सप्लाई प्रोजेक्ट। सबैभन्दा पहिले सबैभन्दा इम्पोर्टेन्ट क्वेसन के आउँछ त? सिम्पल, आजभन्दा 20-30 वर्षपछि यो सहरलाई कति पानी चाहिन्छ? सो हाउ डु इभन बिगिन टु आन्सर द्याट?
Well, यो हाम्रो estimation नाइ कुनै पनि water supply design-को, the absolute first step हो। र यसलाई राइट गर्नको लागि, we need to know 3 key things.
So, के हो त यो तीनवटा core factors? Okay, first is per capita demand. Simple termsमा, एकजना मान्छेले एक दिनमा एभरेजमा कति पानी युज गर्छ? Second, base in design period. बेस पिरियड भनेको प्रोजेक्ट बनाउन लाग्ने टाइम, एन्ड डिजाइन पिरियड भन्या त्यो सिस्टमले कति वर्षसम्म काम गर्छ। अनि थर्ड, अफ कोर्स, द फ्युचर पपुलेसन। त्यो डिजाइन पिरियडको एन्डमा पपुलेसन कति हुन्छ? वी हेभ टु प्रिडिक्ट द्याट।
Total demand. सुन्ने बेला धेरै टेक्निकल र कम्प्लिकेटेड लाग्छ हैन? But trust me, it's not. It's just a mix of a few smaller, एकदम easy parts. So, let's break them down one by one.
Okay, first up we have domestic demand. यो त नामले नै क्लियर छ, घरमा युज हुने पानी, for drinking, cooking, नुहुना, लुगा धुना. Of course, यो amount different हुन्छ depending on factors like climate कस्तो छ or मान्छेको living standards कस्तो छ.
Alright, now this is super important, especially for Nepal. हाम्रो Department of Water Supply and Sanitation, यानी कि DWSS, ले specific standards set गरेको छ. Rural एरियामा it's 45 LPCD, that's liters per capita per day. Semi-urban को लागि 65 र urban area को लागि it's between 100 to 135. साथीहरू, यो नम्बर चाहिँ डेफिनेटली याद गर्नुहोला, एक्जाममा आउने चान्सेस धेरै हाई हुन्छ।
पानी घरमा मात्र त चाहिँदैन, राइट? सो वी अल्सो हेभ टु थिङ्क अबाउट लाइफ स्टक डिमान्ड, एनिमल्सको लागि। त्यसपछि आयो इन्स्टिट्युसनल डिमान्ड फर स्कुल्स, हस्पिटल्स, अफिसेस, देन देयर इज इन्डस्ट्रियल डिमान्ड फर अल द फ्याक्ट्रिज, अनि म्युनिसिपल डिमान्ड पनि, जस्तै रोड सफा गर्न, पार्कमा पानी हाल्न, र एकदमै इम्पोर्टेन्ट कुरा, वी हेभ टु अकाउन्ट फर लसेस, किनभने पाइपबाट पानी लिक हुन्छ, समटाइम चोरी पनि हुन्छ, सो त्यो पनि हिसाब गर्नु पर्यो।
अनि देयर इज वान मोर, फायर डिमान्ड, आगो निभाउन चाहिने पानी। नाउ यसको लागि धेरै फर्मुलाजहरू छन्, तर डोन्ट प्यानिक, तपाईले यो सबै मेमोराइज गर्नु पर्दैन। Generally, we focus on just 1 or 2 key formulas, like the one from the Indian Water Supply Manual.
So, what's the main takeaway here? Total demand is just, well, adding everything up. We take domestic, livestock, commercial, industrial, fire demand, and the losses. Just add them all together. It's that simple, really.
Okay, so water demand kekele bancha, त्यो त बुझ्यो. Now for the next big piece of the puzzle, future o लागि कसरी plan गर्ने? Well, that all comes down to one thing, forecasting population growth.
So यहाँ हामीसँग दुईटा इम्पोर्टेन्ट टाइम फ्रेम्स हुन्छ। एक, बेस पिरियड। यो भनेको प्रोजेक्ट बनाउन लाग्ने टाइम, which is usually around 2 to 3 years. अनि अर्को, डिजाइन पिरियड। यो भनेको त्यो सिस्टमले कति वर्षसम्म सर्भिस दिन्छ, maybe 15, 20 or even 30 years before it needs a big upgrade.
And check this out. It's a perfect example. Let's say survey suru vayo 2017 ma. With a 2-year base period, project complete vayo Rapani Anathelio 2019 ma. Dispachi, if we have a 15-year design period, iska matlab, hamara system lay 2034 samako population lai service dina sagnu parcha, simple, right?
So population forecast गर्ने तरिकाहरू के छन् त? First one is the arithmetic increase method. यसलाई simple interest जस्तै सोच्नुस्. It assumes कि population हर साल एकाइ नासले एकदम constant amountले बढ्छ. यो मेथड पुरानो, already developed, stable cityहरूको लागि ठीक हुन्छ. For example, maybe भक्तपुर.
Okay, next method is the geometrical increase method. यो चाहिँ एकदम compound interest जस्तै हो. It assumes the growth rate is a constant percentage. So, यो नयाँ एकदम fast growing cityहरूको लागि धेरै accurate हुन्छ. And hey, pay close attention here, because यो method नेपालमा धेरै नै use हुन्छ. So it's super important for your exams.
Alright, धेरै theory भयो. अब यो सबैलाई प्र्याक्टिसमा लगाऊ. A real numerical problem solve गरियो भने यो सबै concepts एकदम मजाले clear हुन्छ. Okay, so here's our problem. हामीलाई 1970 देखि 2000 सम्मको census data दिएको छ. र हाम्रो task के हो? Simple. We need to estimate the water demand for this town for the year 2030.
So यहाँ हेर्नुस्,
population forecast in नौवटा method, arithmetic, geometrical and incremental increase use गरेर calculate गरिएको छ। तर notice गर्नुस् त, geometrical methodले सबभन्दा धेरै population estimate गर्छ। किन? Because it assumes compounding growth, which makes more sense for a city that's growing fast.
And as you can see, the geometrical method gives us a projected population of 96,301 for 2030. So, for our final design calculation, this is the number we're going with.
Great! Abahami-sanga population cha. So now we calculate the total design demand. The process is pretty straightforward. First, we multiply our future population by the per capita demand. Then, we add the fire demand. And finally, we add a 15% allowance for all those losses we talked about.
And voila! After all that, we have our final answer. The design demand for the town in 2030 comes out to be about 13.7 million liters per day. See? It's not that hard. Just follow the steps and you'll get there.
Okay everyone, exam nazik aisakyo. So it's time for some quick revision. If you're cramming at the last minute, these are the key points and formulas you absolutely need to remember.
Yo slide ko screenshot linuhos. Seriously, these are the must-know formulas for this chapter. Design year ko formula, per capita demand, geometrical increase, and of course total demand. Yo चाहिँ एकदम धेरै practice गर्नुस् है.
And last but not least, don't forget the factors that can change water demand. Kura simple cha, for example, city tulo vayo or climate dere hot vayo vane, demand bodacha. Paniko quality or pressure rambro vayo vane pani usage bod nasekcha, even paniko costly frog parcha. Yo vaivama or short questions ma sudna sukne ekdam common topic ho, so be ready.
So, to wrap this all up, here's a little something for you to think about. Kathmandu Valley. It's a very interesting case, right? It's an old established city, but at the same time, it's growing like crazy. So, based on everything we just learned, which population forecast method do you think is best for Kathmandu today, and why? Think about it. And with that, all the best for your exams.